Swayam Prabha. Digital India. Educated India.
This maritime engineering, as you see, is a very special program which has got multidisciplinary input from mechanical, civil, structural, aerospace, naval architecture, chemical engineering, electrical, electronics, applied mechanics. It's a multidisciplinary program. You will find this program is completely different, dedicated to industrial training and thorough capacity building on the new trade of maritime sector. It's a grooming economy which will give you a lot of job opportunities and research frontiers as far as India is growing. And the Blue Corridor effect, which is planned by the Government of India, is one of the important mission which requires maritime engineering growth to happen in the country. So this program caters to expected that capacity building in this program.
Friends, this is part of a material science engineering laboratory which becomes one of the teaching aid for the maritime engineering program. So when you talk about materials innovation in maritime industry, though concrete and steel have been conventional candidates of choice for engineers, for example, we have titanium vessels, high-speed craft boats made of fiberglass. These are all advanced materials which actually do not come across conventional standard design code of practices. We conduct box furnace test, tube furnace test, vacuum arc melting, induction melting, vacuum induction melting, vacuum sealing unit, which are all present in this laboratory is a small segment of material science laboratory. Friends, a typical furnace where the operating temperature for testing specimen can go as high as 12 degrees Celsius. Generally at room temperatures and ambient condition, the mechanical properties will not alter much. As you see in the course lectures, you will notice that strength of the material get degraded when the temperature rises beyond 600. Therefore, when you talk about fire resistant design, you must also choose an alloying element such a manner that the strength doesn't degrade beyond 600 degrees Celsius at all. Welcome to the ambience of IIT Gandhinagar lecture theatre. This is one of the interesting classrooms where the maritime engineering classes will be conducted. We have got state-of-the-art projection facility and good audio-visual recording systems. Once the lecture is over, you see the system here. We can generate the PDF files of the lecture directly and you can email the PDF files directly to your email IDs. So it's a state-of-the-art facility we have in IIT Gandhinagar where the lectures are lifetime recorded and shared with the students immediately. This is the IIT Gandhinagar library. This has got all collections of books which are referred as the standard textbooks and references for the course and the program. It also has lot of online editions of design code of practices and reference materials and e-collections of various video lectures of international courses and programs related to maritime engineering. We will be taking you around to the advanced material manufacturing units. So you will have state-of-the-art facilities available at IIT Gandhinagar. So welcome to the program to join MTech and PhD at IIT Gandhinagar Maritime Engineering. So please try to enjoy and take the advantage of this to the maximum. Welcome to the program and welcome to IIT Gandhinagar. Friends, welcome to the lecture 7, which is the continuation of discussing new generation platforms. Now we will discuss about the regasification platform. Friends, in maritime sector, LNG processing has taken up a big leap in India as well as in other developing and advanced countries. LNG processing, if happens offshore, that is in sea, it is more economical and cheaper because the majority of money involved in LNG processing to bring it to offshore or from offshore to onshore through pipelines is the most expensive and most hazardous process. If you look at this kind of applications in other parts of the world, LNG carriers, LNG shuttles have been used to transport LNG from an explored platform offshore and bring it to onshore. Whereas the capacity of these shuttles and tankers are very limited and they involve huge money because LNG is generally stored in cryogenic temperature, and a large movement of the vessel carrying LNG can also cause lot of fire hazards and accidents to the LNG shuttle. So, LNG offshore is a very interesting and very advanced thought process coming up in maritime sector, which saves lot of money as well as we can avoid the accidents happening in sea. So, in the context of blue economy and revolution towards blue economy and blue corridors, LNG processing offshore is one of the vital areas where advanced countries are now focusing. So, why not we discuss this small part by a kind of a platform in this particular lecture on Maritime Structures course offered with Swayam Prabha at IIT Gandhinagar in the Department of Maritime Engineering. Friends, welcome to lecture 7, New Generation Platforms 2, where we will discuss about the conceptual design and layout of a regasification platform. Regasification is a term which is actually LNG conversion process which is happening offshore. Please note friends, this concept is not novel and new. This happens, but in a very limited quantity, because offshore LNG processing and regasification is a very expensive process. If it is done in onshore by through pipelines, it is most hazardous and dangerous. We already saw in the previous lectures, innovation in the geometry of offshore platforms has significantly enhanced the operation from deep to ultra deep waters. To recollect the water depth, we already said a thumb rule can be applied to find out the water depths as classifications from shallow, intermediate, medium, deep and ultra deep waters. So, when I say ultra deep, I am referring to water depth more than 2000 meters. We know as we wanted to see or check the depth of water as 2000 meters, you are very few kilometers away from the shore. So, you are completely deep offshore where the accessibility of these safety systems and processing systems are completely limited because you are very much away from the coast. You are totally offshore from the coast. Furthermore, friends, once the oil is explored in terms of liquid natural gas, regasification becomes a very critical process. Regasification is critical in LNG supply chains, enabling the conversion of the stored LNG back to natural gas for continuous energy delivery. So, generally this does not happen offshore, this is done usually in onshore, and first the LNG is transported to onshore and then this regasification happens. But we are now explaining a concept where the regasification can happen in offshore, but there are some consequences when you start doing this process on an offshore platform. Let us see what are those consequences, how they can be mitigated by a simple preliminary geometric design, which is again called as a new generation platform. Friends, we already recollect that if I have a mass which can have a freedom to move along 3 axes x, y and z. Along x we call this as surge, along y we call this as sway, and along z this is heave. We also have a freedom of this mass to rotate about x, which is denoted as roll, to rotate about y denoted as pitch, to rotate about z axis denoted as yaw motion. So, again we recollect what we learned in the previous lectures. X, y, z displacements are possible, rotations about x, y, z are possible, whereas displacements along x, along y are flexible, displacement along z is rigid. It means I wish to control the heave motion because displacement along Z is heap. Whereas I wish to allow surge and sway freely. Furthermore, if you look at the rotations, rotation about X, about Y, I want to control, whereas rotation about Z, which is yaw, is again free. So, when you have a platform which has got a few degrees of freedom flexible and a few degrees of freedom rigid, we call this platform as hybrid platform. Hybrid concept is good in complaint systems and new generation platforms because this induces high degree of flexibility in the design as well as in the behavioral responses of the platform. However, large displacements along X and Y is also a botheration. So, now the concern what we get here is if the displacement along X and displacement along Y, which is otherwise termed as surge and sway, becomes very large, okay, then this is a concern. One may ask me a question, why this should be a concern if I am able to activate the recentering of the body? Recentering is a process by which the body or the motion of the body is brought to equilibrium position dynamically by an internal action activated within the system in the presence of forces. We agree that is correct what you are recollecting, but this will also happen with the same extent of displacement. My concern is not that recentering happens or not. My concern is if these displacements are larger, then what happens to my LNG processing? That is the question what we are going to ask. If they are larger, the large displacements during regasification are completely unsafe, friends. You cannot allow large displacements. Now the question comes, as intelligently thought by a few of you, can you use rigid platforms for regasification? Okay? Can I use rigid platforms? Because I do not want displacements, I do not want rotations. Rigid platforms like stiff platforms, they do not have rotations and displacement, they are very minimum. Can I use them? The answer is what you already know, but still you cannot use rigid platforms. You cannot use them. Can you tell me why? Because LNG or CNG happens at a great water depth beyond 2000 meters, friends. At this depth, these platforms are very expensive and they cannot be constructed because they also have lot of complexities in construction or in commissioning, and the substructure will be very expensive and it will be a waste, because the substructural system which will also be of steel will get into a greater water depth which is non-reusable. So, therefore, friends, I cannot go for a rigid system. I have to go for a compliant system alone. Yes, so we agree that compliant systems is the only option we have. Agreed. But the compliant systems have large displacements. These large displacements are completely unsafe because they disrupt cryogenic pipelines, containment systems and safety valves present in this process. In the regasification plants, which happens at cryogenic temperature, these pipelines and containment systems will be disturbed largely when you allow large displacements on the compliant platforms. Then what is an alternative? yes, we have come out with the concept of what is called in the literature buoyant leg storage and regasification platform, what we call as BLSRP. So, now we borrowed the idea of buoyant legs from the Triceratop and placed them on this platform. Let us recollect what was the idea of a Triceratop. Triceratop had a deck, then they have pipelines or they have buoyant legs, which are anchored to the seabed with teethers. The most phenomenal component which is very vital and crucial in Triceratop is the ball joint which is placed between the deck and the leg. But these ball joints help me to partially isolate the deck from the legs, which you have seen in the previous lectures. So, now when I use this idea, they undergo large displacements, which is very dangerous for regasification. Therefore, the superstructure and the substructure and the ball joint need to be modified. Okay, that modification is what is conceived in BLSRP. It's a new generation floating offshore platform designed especially for storage and regasification of LNG. Let us see how this conceptual design looks like. Friends, please note that BLSRP is still a conceptual design. Of course, preliminary experiments, studies have been conducted at IIT Madras and now being completed in IIT Gandhinagar as well to ensure that this proof of concept is becoming gradually valid, with some more studies being aimed to commission this platform in ultra deep waters. So, let us see what are the existing technologies we have for storing and regasification of liquid natural gas. One of the common thing which is used, which is very safe and which people commonly practice, is an onshore storage and regasification. So, if you look at this figure, the whole process of regasification, which consists of the storage tanks, the low pressure pumps, the electromechanical equipments, all happens onshore. So, to do this, you have got to first bring CNG or LNG from offshore explored location to onshore. This is generally done with the tankers, shuttlers or with the pipelines. All the three are equally hazardous and susceptible to accidents. Therefore, the cost of processing regasification onshore becomes prohibitively high. The second alternate what people do is they do regasification on an LNG storage plant itself. Okay, they have a vessel, sailing vessel which is completely floating like a ship. They modify the deck of the ship, use this to store LNG at cryogenic temperatures and do regasification on the floating vessel itself. This is another technique what people generally follow. But one of the important difficulty here is the capacity. The capacity is very limited and it is very highly susceptible to fire and collision accidents because being a vessel. The third one is simply floating storage unit, no regasification. Okay, what they do? They collect LNG, store it and bring it to onshore. And this is an expensive process because this will have a prohibitive expense towards carrying LNG from offshore to onshore. The fourth concept is what we are now discussing, is the idea of proposing a platform offshore itself which can do regasification. So, LNG tankers are provided on the top itself, and then there will be a hinged joint which connects the deck to the legs. So, the concept of hinged joint is borrowed from Triceratop. However, if you remember in Triceratop, the legs were vertical and they were axially tensioned, but here the legs are inclined equally in plan. Let us say 6 legs, 8 legs, they are equally inclined in plan, and the circular deck is where the regasification happens. But then what is the difference between the joint which is provided in Triceratop and in BLSRP? Let us look at the explored view of this joint. This joint will not allow to rotate 360 degree. It can allow to rotate only on one plane. For example, look at the screen here. I am holding this joint here. The ball joint in Triceratop is able to rotate 360 degree, whereas in this case can rotate only on one plane. So, there is a constrained motion imposed on this joint for this particular system. So, in Triceratop this was 360 degree, whereas in BLSRP it can rotate only on one angle. Okay. So, that is the imposition we have here, and we call this as a hinged joint connecting the leg to the deck. Now, let us see, when you have FSRU, that is floating storage regasification units which are mobile, they can be relocated, they face large displacements. BLSRPs are permanently moved, therefore, the displacements can be somewhat less and they can be controlled. Buoyant legs with hinged joints partially isolate the deck motion. We already saw that in the previous lecture. By providing a ball joint, the deck rotation does not get transferred to the legs, as well as the leg motion does not get transferred in rotation to the deck. So, the rotational degrees of freedom like roll or pitch in a vessel which is phenomenally high will not be transferred to the deck anymore when you use a buoyant leg storage platform moved to the seabed. The preliminary studies of this conducted in 2017 by Chandrasekaran and Loganath ensures that these platforms ensure better stability and safer regasification. So, buoyant leg storage regasification platform maintains very high stability by providing positive metacentric height throughout its lifespan. The platform offers stability against the lateral loads by its unique design. Therefore, it is a classical example of a form dominant design in maritime structures. This can be a good candidate for storing and regasifying LNG. A typical BLSRP looks like this. This is a front view of BLSRP. Friends, the water depth what we are talking about is more than 2000 meters, where a fixed platform cannot be commissioned. We can only go for floating structures. So, this is the top view of the BLSRP, where the legs, the buoyant legs are equally inclined with respect to any wave direction. Look at any wave direction, you can make them equally inclined. You can have either 6 legs, 8 legs, 12, 4, etc. So, we have taken a concept of 6 legs which is shown on the screen here. One can also extend this number of legs as it is required when the diameter of the deck is very large. Friends, let us pay attention for our understanding to the components present in an LNG processing platform. Let us see, the one which I am indicating is the deck, 2 are the hinges. Okay, let us mark it here. 1 is the deck which is here, 2 is the hinge which is here, 3 are the buoyant legs, this one are the buoyant legs which is here, and of course at the bottom these legs are connected to the teethers, correct. These are teethers. So I can now say teethers are also understood. As I said, we want to control the large rotational responses of this. We introduce something called response control mechanism, which is indicated here. So what we do, from a central piston which is suspended from the deck, we connect all the legs with a piston cylinder arrangement. As the leg keeps on moving outside, this piston will bring them inside. When the legs come inside, this piston will move the legs outside. So the response control of the leg is automatically deciphered using this mechanism, which in turn helps to limit the rotation of the leg. And of course, we understand ball joints will not allow this rotation to transfer to the deck at all, and the deck remains almost horizontal, which is required for processing LNG at cryogenic temperatures. So, this is what we see here is the sixth one, which is the LNG tanker. These are all LNG tankers, and we other know the parts like crane, which is here, and 8 is the service platform. Of course, you can locate the helipad easily on the sketch. 8 is the service platform here, and helipad, helicopter, living quarters are all known, common. Regasification is happening here. This is a regasification unit. Okay. Then LNG pipelines, natural gas pipelines are located within the system of electromechanical to do this processing. Then we have the control mechanism provided here, which consists of a fixed rod, a spring, a piston and a pin and a bracket, which helps me to control the motion of the leg to and fro or inward or outward from the center. Let us draw a figure and explain how this happens. Let us say I have a platform deck, and if you want to connect the leg to an angle, you want to connect the leg to an angle using a ball joint. Okay, from the center, I want to limit this rotation. So, what I do? I provide a suspended arrangement of hydraulic cylinder, which is connecting this by a piston to this by a piston and cylinder to this, like a damper. Okay. Now, when these legs move outside, this piston will drag it inside. When the legs moves outside, this piston will drag it inside. When the legs moves inside, this piston pushes the leg outside. So, this control arrangement helps limiting this motion of the leg, which will not get transferred to the deck because of the ball joint. So, as a result, the deck remains completely horizontal, which can carry LNG operations or regasification operations. Having said this, let us see how quickly the equation of static equilibrium looks for this platform. If I say the buoyancy is the displaced volume related proportional force acting upward, this should be equivalent to the sum of the load of the platform W, which is mass of the platform, then mass or weight of the response control mechanism, plus the vertical component of the forces acting from the buoyant legs. A typical size of a buoyant leg platform proposed for regasification, the diameter of the deck is about 100 meters. It is huge number, friends. The diameter of each leg is about 22.5 meters. Proposed is 6 legs now. Operational depth initially 600 meters. And these are the significant parameters which are used in the analysis for this kind of platform in a preliminary study. Most importantly, friends, by providing a response control mechanism which can also cause variable buoyancy because of its suspended volume, the volume of the response control mechanism actual is kept equivalently same, so that the period of the platform with and without response control mechanism does not change significantly. So, that is the initial idea in dynamic perspective which is imposed on this platform with response control mechanism. Now, what we have in our mind is, we have a complaint platform which is a new generation platform which is now intended to be used for regasification. Regasification cannot happen because the displacements are very large. The displacements of the deck should be controlled. Rotations are more dangerous. We put ball joints between the leg and the deck, and ball joints cannot sustain larger rotations. Therefore, we provide additional response control mechanism with the piston rod arrangement which can now control the inward outward motion of the legs. Now, interestingly, friends, when you look at the equation of motion for the buoyant leg alone, so let us say inertia component, damping component, or energy dissipating component, elastic restoring force component, and the force which is coming from the magnetorheological component damper will be all equivalent to the external force coming from the wave and wind and current. Okay. Now, this mass, which is called as an effective mass, will be mass of the structure plus added mass. Effective damping will be damping of the structure plus radiation damping coming from the hydrodynamic parameters. Effective stiffness is stiffness of each leg plus hydrodynamic stiffness offered by the motion of the platform, and external force is the sum of the external transmitted force which is coming from wave, wind as well as motion of the platform. So, when the leg is moving outward, suddenly the dissipation will bring the leg inside and the force displacement reduced. Then when it moves inside, again it is controlled and then the force is increased. When the force touches the maximum value, the leg is again pushed inward or outward. So, this loop keeps on travelling in a specific pattern from here, a specific pattern from here in a specific pattern, and we call this as Bouck-Benz hysteresis loop model, which is a combination representing the linear damper, the spring damper, and a Bouck-Benz model. So, this is the model being deployed in the dynamic analysis of the study of this platform, which indicates the mathematical formulation of this using this equation, and the damping force of the damper can be estimated using this equation, whereas these parameters are estimated based on Bouck-Benz hysteresis loop model. So, let us look at the natural period of vibration of this kind of platform without response control and with response control. Surge and sway has about 130 or 140 seconds period, whereas heave is about 36 seconds. When you deploy a response control mechanism, there is no significant variation in the periods, because the conceptual design is based on this concept that the volume displaced by the response control mechanism is equivalent to the one in the absence of this, so that the periods do not change significantly. Okay. However, the damping ratio has a variation in the heave motion. Okay. Having said this, we did an initial study and then we realized that the power spectral density function looks like this for a wave approach angle at moderate C state. So, one can see in heave degree of freedom, when we employ the control, uncontrolled motion is going very high, whereas when you control them, it is very limited. See here. Okay, in terms of frequency versus the power spectral density function in heave degree. So, the heave motion is significantly controlled, which is required for regasification platforms in offshore. So, friends, let us look at the summary here. So, we discussed about a regasification platform, which is buoyant leg storage and regasification platform, which is a conceptual model. Studies and experimental studies and numerical conducted at IITM and IIT Gandhinagar proves or validates the proof of concept. It validates the proof of concept. Therefore, these platforms, when the response is controlled, can be used for regasification. So, friends, look at the, I will just rub this. Look at the phase velocity plot, which is shown on the screen here. As we saw in the previous lectures, displacement versus velocity will help us to know how they are stable. So, this platform shows a very high stability because it is more or less concentric, but the velocity is proportionately larger with respect to the displacement, because it is more or less circular. An elliptical trajectory is considered to be more safe and more stable. So, the platform is not as safe as you talk about triceratops, but the response control can be achieved and useful for regasification applications. So, friends, in this lecture we learnt about the new generation platform useful for the modern era for regasification. We understood the necessity and the geometric design of this platform in a very nutshell, showing some experimental and numerical results, which you can also read additionally from the references cited in the website and portal of SwayamPrabha. Namaste, thank you.